Welcome to problem number 2 from the H10-4 homework. The directions state, find the sum of each of the following series if n represents the number of terms in the series. Write your answer in simplified form. So letter A, we have this series, 8 plus 12 plus 16 plus ... all the way up to the term 4n plus 4. All right, so because we don't know the number of terms, we don't actually have the last term. This just is in that general form that we talked about in the notes. So the first thing we want to look at here, right? I just want to make sure we're pointing out here, right? This expression, right? Since we don't know the number of terms, this is like our nth term still, right? This is like a sub n is the same thing as like 4n plus 4. This is 8 is like our first term, right? This is a sub 1, this is a sub 2, this is a sub 3. And we can get these values, like the 8, just by plugging in 1 for n, right? If we know that a sub n is equal to 4n plus 4, this is like your equation for your nth term, okay? That's what this expression will always be. If you can find that expression or the rule, the explicit rule, okay, that's what this is. So let's say I plugged in 1. A sub 1 is going to equal 4 times 1 plus 4, which is 8, and you see that's why that's our first term. If I plug in 2, a sub 2 is 4 times 2 plus 4, which ends up being 12. You see that gives us our second term. So this right here is the same thing, right? It's just our a sub n equation for this series. Now, what are we going to do with this information? Well, we need to find the sum, or we're trying to find an expression for the sum. So we're going to say here, the sum of n number of terms is going to equal, right, our first term plus our nth term times half the number of terms. So we'll substitute in the values that we know and then simplify it down. We don't know what n is, so this is still s sub n. And then we know the first term is 8. And we're going to add to that, instead of using the a sub n, we're going to put in the 4n plus 4. And then it's still times n divided by 2. If we simplify inside of here, this is the same thing as 4n plus 12, right, times our n over 2. And then we can distribute that through there. We'd have 4n squared over 2 would be 2n squared. And then 12 times n is 12n divided by 2 would be 6n. So we get 2n squared plus 6n is the expression for the sum of n number of terms. That's what we're looking for here in part A on this problem. Now let's go ahead here and let's do the same thing with B. So with B, we've got our first term here. Our a sub 1 is 5, a sub 2 is 1, a sub 3 is negative 3, and then it goes all the way over here until we get to our a sub n. So rather than doing, writing everything out here like I did explaining that there, hopefully that's making sense with the a sub 1, sub 2, sub 3. If I plugged in the 1 into the rule, that's where I get the 5. If I plug the 2 into the rule, that's where I get the 1, and so on. So let's go ahead here and start preparing for our sum. We're going to say the sum of n number of terms, right? I'm going to write just the formula down again. So the first term plus the nth term times half the number of terms. The more you write those formulas, the more that they're going to stick into your head and make it easier to remember them. Okay, I'm not going to require you to do it, but I'm just telling you what I know works. So our first term here should be 5 plus, instead of a sub n, we're going to use the expression that it equals. That would be a negative 4n plus 9. And then we're still multiplying by half the number of terms. We'll simplify inside here, right? We're adding like that quantity or those parentheses there, so nothing's really going to happen. So we're going to have a negative 4n plus 14 when I add that 5 and the 9 together. And we're multiplying that by n divided by 2. Negative 4n times n is going to be negative 4n squared over 2, which would then reduce to negative 2n squared. And then 14 times n divided by 2 would be plus 7n. So we get our second expression for the sum there. Now, if you want to check them, remember, you can always check these. We'll just do that real quick with this letter B, right? Just choose a couple terms. Let's say here that I wanted to just check using these first two terms, 5 plus 1, right? I know there's two terms there. 5 plus 1 is 6. I know that the sum of the first two terms of this series is 6. Now, does that make sense with my rule? Let's see. The sum of the first two terms. Now I'm going to plug in 2 in for n here. I've got negative 2 times 2 squared plus 7 times 2. Make sure you put the 2's in the right spots there. Sometimes that's the part that gets people. 2 times 2 is 4, times negative 2 is negative 8, plus 7 times 2 is 14, and you see negative 8 plus 14 is 6. So I know that the answer that I came up with right here is the correct answer. Don't be afraid to check your answers. You can check this one over here if you wanted to as well. Let's go on to letter C here. It says, use your new expressions for the sum of each series to find the sum of the first 9 terms in both series. Now, being that we have these expressions, right, we can actually find the sum of the first 9 terms without even knowing what the 9th term is. Now, if you wanted to, you could take 9 and plug it in there and figure out what the 9th term is and do it the way you did it in H10-3. Just plugging into the sum equation or the sum formula. But we can just use this equation here. Watch, this is for letter A first. We can say the sum of the first 9 terms should be 2 times 9 squared plus 6 times 9. Okay, so 9 squared is 81, times 2 is 162, plus 6 times 9 is 54. And then all we need to do is add those together. Let's see here. We've got 160 plus 50 is 210 plus 2 and plus 4. So I think it's 216. Sum of the first 9 terms should be 216. Let's just double check it just to make sure I didn't goof that up. 162 plus 54. Yes, there we go. Good. All right, so that's the sum of the first 9 terms for letter A here. And now we'll end up doing letter B. So we'll do that down here. We're going to do the sum of the first 9 terms of, our rule was negative 2n squared plus 7n. So we're going to say negative 2 times 9 squared plus 7 times 9. 9 squared is 81 times negative 2 is negative 162. And then we're going to say plus 7 times 9 is 63. So negative 162 plus 63 should be negative 99. So the sum of the first 9 terms of that series is negative 99. If you have additional questions about this one, please make sure you reach out to your teacher. Hopefully this helps you and makes a little bit of sense. Thank you for watching.